All right, so again, for the record, we will test next Thursday 1.1 all the way through, for sure, 2.1 and maybe 2.2. You would like it if we got through 2.2. Okay, yeah. So anyway, we're looking at now another version of the formal definition of the derivative. We have the formal limit definition, which gives us a function of x. So we set it up, we evaluate the limit, and on the end, we have a function of x that we can then plug into, right? F prime of 3, f prime of 5, whatever. Or we can set it equal to a slope and solve for x. There's another version that is very, very similar to the formal limit definition, and for lack of a better term, I call it the modified, because all we're doing is we're modifying the one that we already have. The only difference is instead of plugging in a specific value of x on the back end, we plug in a specific value of x on the front end. And therefore, we end up with a numeric value, okay, rather than a variable function. This one is, you could also call it the disposable method, okay, because it's only good once, right? Whereas the one that we just did on the quiz, we do the work once, we get a function of x, and then we can reuse it over and over again, right? Just plug in different values of x. So here's what it says. It says the derivative of a function at a specific point, call it CF of C, okay? So like the point 2 comma 5 or 3 comma 8, whatever. It's a specific ordered pair. It's given by this, the limit as, f prime of C is the limit as h goes to 0. That's still the same. F of C plus h minus f of C all over h, right? So what's the difference? Well, let's just put it here for comparison. The formal limit definition, or the FLD, would be f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, right? So again, as I mentioned, the only difference between the one that we should already know, that we developed in context, so you wouldn't have to memorize it, the only difference is we're plugging in that value right away, okay? Modifying it, all right? So let's try it out. Example 5. Find f prime of 1 directly using the modified definition. Okay, f prime of 1. That's the slope of that graph at x equals 1. You want to try and sketch the graph first and see if we can maybe anticipate it? Let's do that. It's always good to do that. What do we know about that function? Do we know anything? We know quite a bit, right? We know that the domain is everything except -1, right? We get division by 0. What type of discontinuity is it at -1? A vertical asymptote, yeah. So I'm just going to come over here. I'm not going to write any of this stuff down, but we'll kind of get a sketch going. We know there's a vertical asymptote here at -1. What's the horizontal asymptote? What's the limit as x goes to infinity? 1x to the first over 1x to the first. They're growing at the same rate. So leading coefficient over leading coefficient, right? It would be at 1. Yeah. So that kind of gives us like a new x and y axis, really. And this is, by the way, a transformation of your 1 over x function. I need one ordered pair. What's the y-intercept? What's f of 0? It would be 0 over 1, which is 0, right? So I know it passes through the origin. So something like that. And now I know it looks something like this. It's going to come up, maybe pass through there. It's going to do that. And then the only x-intercept is 0 when you set the whole thing equal to 0 by setting the numerator equals 0. So on this side, it has to live above the horizontal asymptote. Otherwise, it would cross the x-axis again. Now, you could do long division here, x divided by x plus 1, and you'll see that it's actually a transformation of 1 over x. It's just shifted left and up, and then it's reflected. But anyway, there it is. And now I want to know what the slope is at 1. So I'll use blue for this. Let's say this is 1. Right there. I want to know how fast that graph is changing at that moment. Well, we always read a graph from left to right, so just looking at it, the slope should be what? Positive or negative? The derivative should be positive. It's going uphill. And if I draw the tangent line, again, remember it's tantamount to finding the slope of that line. Just, do you think that the slope is going to be less than 1 or bigger than 1? Do you think it's like less steep than a 45-degree angle or steeper? Maybe less steep, right? Because we're already to the right and we know the slopes are decreasing, right? As the y values increase, we know the slopes are decreasing. It's flattening out. In fact, I could tell right here that the slopes are approaching 0, right? But they don't ever reach 0. Okay, so I'm just guessing that it's going to be some positive number, maybe between 0 and 1. But, you know, let's find it. Let's find it directly using the modified form. So here we go. F prime of 1, it's going to be the limit as h goes to 0 of, and I'm going to go ahead and write it out. It's going to be f of not x plus h, but 1 plus h, minus not f of x, but f of 1 all over h. So it does help for you to write it essentially in definition form using that specific value of x. Now we're working straight down. We got the limit as h goes to 0. F of 1 plus h, how do we evaluate that? Well, we replace both of these x's with 1 plus h. So we get 1 plus h all over 1 plus h plus 1. Minus f of 1 is replacing both x's with a 1. 1 over 1 plus 1. And then all of that is over h. And this kind of looks like a house of cards that we're building, right? No one sneeze. Let's work down. Let's simplify. Early and often, baby, like voting for Cade Wenzel's kick. 1 plus h in the top, and then 1 plus 1, that's over 2 plus h. Nice. Minus 1 over 1 plus 1 is 1/2, and it's still all over h. Okay. So if I use direct substitution at this point, I'm going to get 1/2 minus 1/2, which is 0 over 0. Hip, hip, hooray. Hip, hip, hooray. Because that means that not only do we get to do more work, but it probably means that we set it up correctly. So algebraically, I need to somehow divide out the h in the bottom. That's the bad guy. Phaedo is not going to work because factoring divide out is not going to work. I'm not going to use the trig stuff that we memorized. Ratcon doesn't even work. What? Lick 'em over lick 'em. Complex fraction, right? Complex fraction. So if you look at your two miniature denominators, that would be 2 plus h and 2. When in doubt as to the least common multiple, you can find a common multiple by taking their product, yeah? And so that happens to be their least common multiple as well. So 2 times 2 plus h, and then 2 times 2 plus h. One upstairs, one downstairs. Now, I'm telling the pre-calc kids, if you want, notice upstairs in my expression that's above this main blue line, they have bunk beds, right? Numerators and denominators. So if you want to give the 2 over times 2 plus h a bunk bed by putting it over 1, it helps you when you distribute possibly, right? Because you can put anything over 1. All right, now we're going to distribute in the top. The limit as h goes to 0. Again, you don't have to draw the line, but we're going to distribute there, and then we're going to distribute there. So when I distribute in the first one, your 2 plus h's will divide out. And what are we left with in the top bunks? We're left with a 2 times the quantity 1 plus h. So let me draw the ground floor. 2 times the quantity 1 plus h. We destroyed the bunk bed. Minus, when I distribute to the second, the 2's divide out, and we're left with a minus 1, muy importante, times the quantity 2 plus h. I'm going to put it in parentheses because if I try to distribute as I write it down, I'll make a mistake. And in the bottom, nothing divides out. I just multiply straight across. So I'll call it 2h times 2 plus h. It's completely factored. We don't distribute. So I just make the factors in pretty format. Yeah? All right, if you plug in a 0 now, we got rid of the complex fraction. If you plug in a 0 now, you'll still get 0 over 0. So at this point, it's like hitting it with a little sledgehammer. We just need to expand it out, right? So we get 2 plus 2h minus 2 minus h all over this. Beat the bot. All right, and I have that. And now I need a new column. Boom. Algebra, right? Inch by inch, it's a cinch. Staying organized and working straight down helps you. All right, so equals. What happens over here? Let's see. My 2's cancel, right? Make a 0 pair. And I'm left with 2h minus 1h, which is just an h. So equals h over 2h times 2 plus h, right? And now, look what happens over here. You can try to hide little h factor between the comfort of 2 and 2 plus h, but we see ya. We see ya. And that leaves a 1. And now we eradicated the 0 over 0 problem. So now we can use direct substitution again. And I'm left with 1 over, plug in a 0 for any h, and we get 2 times 2, which is 4. Yeah. So there it is. There's the answer. If you want to bring all the way down now, right? F prime of 1. F prime of 1. There you go. So that ended up being the slope of this line. Is that reasonable? Yeah, it's right in kind of where we were expecting it. It looks like it's past the 45-degree point. So it's flat, but it's still increasing. It's a fourth. All right, so if I wanted to find the slope now at 2, I'd have to do this whole thing over again, right? The whole limit process, which is why we like doing it with an x. We do all of the fun algebra one time, and then on the back end, we can let x be a variable and plug and chug, right? But why do we need to know the modified form? Well, because College Board will give you questions involving the modified form. So here's what you're expected to know how to do. You're not going to have to set up on the AP exam using the modified form and evaluate it. What's going to happen is they're going to give you a modified form set up, okay, very similar to this line here. Let me highlight it. Very similar to this line here. And they're going to ask you what function f of x did you use to generate this, and at what value of x are you evaluating it? And so you're going to be like, oh, that looks like it's the x over x plus 1 function evaluated at 1, okay? So you're going to have to like deconstruct it, right? Like when you go to like Wendy's and you buy a cheeseburger but you don't eat it, you go home and you carefully disassemble it and you're like, so that's what they put in here to make it so darn delicious, right? Or whatever. You have to deconstruct it. All right, sweet. Now let's do part B. Find the equation of the normal line to this function at x equals 1. I don't think we've seen that this year yet, normal line, right? Well, normal line is kind of like a normal force. In physics, a normal force always acts orthogonally to the plane, also known as perpendicular, okay? So let's write this. A normal line, ooh, a highlighter again, is perpendicular to the tangent line. Okay, exclamation point, exclamation point. So we're going to be writing equations of lines all year long. What do we need for the equation of any line? We need a slope and a y-intercept would be great, but if we don't have a y-intercept, any point will do, okay? We need a point and a slope for a line. We need a point and a slope. But really, we don't even need a point. All we really need is an x location and a function, right? Because we could generate our own y value, which would give us the point. And of course, we could generate our own slope at that point by using the big D derivative, okay? So all we want to do then is find the tangent line slope, which is the derivative, and then take the perpendicular slope to that. So if the normal line is perpendicular to the tangent line, numerically, how are they related? It's a 90-degree angle. So let's say I know that the slope of the tangent line is 5. What would be the slope that's perpendicular to 5? Negative 1/5. They are opposite reciprocals. Opposite reciprocals of the tangent slope. What's another name for the tangent slope? The derivative, right? So once you find the derivative value at 1, which I think we just did, right? The opposite reciprocal of that will be the normal slope. Let's go ahead and draw the normal line real quickly, the normal line. Since I drew it over here, I'm going to use beefy brown. Draw something that comes in, beefy brown. Oh, it didn't snap. Snap. There we go. Something like that. And of course, it intersects the tangent line at a right angle, right? So I'm trying to find the equation of that line. So let's go ahead and gather our posies, all right? We need a point and we need a slope. The posies are going to be the flowers that we put in our flower arrangement. Once they have them in front of us, then we can just put them in the vase. So the point is going to be the same point right here. The point of tangency is the same as the point of normalcy. I think we've already found the y value. It's 1 comma. And just for kicks, how do we find the y value? Well, same thing we've been doing in algebra since algebra 2, right? F of 1 is 1 over 1 plus 1. It's a half. It's the same value that we found right here, right? Remember that was f of 1? So the ordered pair, the point is 1 comma 1/2. So we got the point. And now the slope, let's be careful here. The slope, I'm going to use m subscript tangent. Do we know what the tangent slope is at that point? It's what we just found, right? Which was 1/4. So I'm going to write that down. Tangent, right? Tangent. And so now underneath there, I'm going to put norm. I'm using it kind of like a subscript. It's the perpendicular slope. And what will it be? -4. The opposite reciprocal, okay? So now I can really write the equation of the tangent line or the normal line or the tangent line or the normal line. I got all the ingredients. It's like, what do you want? Oh, you asked for the normal line? All right, let's go ahead and just drop it in. So remember, Taylor form is what we use. Let's write that out one more time. Taylor form is y equals the y value, y sub 1, plus the slope m times x minus the x value, x sub 1. The only minus that's built into the equation or the formula is x minus. We add the slope. Now, of course, if the slope is negative, it'll make it. So let's go ahead and label. It says the normal line. So I didn't get to do this yesterday because the bell caught us, but you always want to kind of label things. So normal line, colon, right? When you put a colon, that means you're listing something, right? Here's the normal line. I'm going to list it. Now, you could call it plain old y if you want, y equals, but you know what? I'm going to give it a specific name. I'm going to call it n of x for normal. Hey, Mr. G. Oh, man. How is it not, right? Yep. All right. So y equals. Oh, big old hands, skinny legs. Y equals the y value, which is 1/2, plus the slope, which will be plus -4, which is -4, times the quantity x minus the x value. Okay? Now, again, you could call it plain old y. That's fine. But you're going to see later on we're going to use these lines, so we might want to give it a specific name, right? The y value plus the normal slope times x minus the x value. So notice how easy it is when you have the things right in front of you. I like to have them right in front of me, and then I drop them in. Now, just for kicks and giggles, right, like for Mr. Garcia's sake, let's just go ahead and write the equation of the tangent line. It pretty much comes for free. I'm going to call that one t of x for tangent line. It's still going to be the same y value, 1/2, but now it's going to be plus the slope, which is plus 1/4 times x minus the x value. In the Taylor form, the only difference visually is the slope. Now, they will have different y-intercepts. If you want to put them both into slope-intercept form, don't think that that's the only difference in the lines. If you distributed the -4 and you distributed the 1/4 and then combine them each with the 1/2, you're going to get a different constant, okay? But in this form, that is the only noticeable visual difference. And you don't have to put your equations of lines in any specific form, unless it actually says it. But it's not going to say that. It's just going to say to write the equation of a line. So put it in Taylor form. As Chili's used to say, as their pickup window motto, get in, get out, and get on with your life.
I didn't even.
Okay. All right. Everyone good? Yeah. And the bell is going to ring. So we'll pick up with example 6 tomorrow. There is no advisory. There's no quiz either. So I'm going to push it tomorrow. We'll see how far we get. If we finish, it'll be a miracle, right? So it looks like we'll finish on Monday, and the worksheet will be due on Tuesday, okay? Y'all have a great day. Vote till 7 p.m. Tell your parents, tell your friends, employ the masses. We need to get this done. Our lead is shrinking. Goodbye. Have a great day.